Hi all. So this section is matrices and applications. This is part number 2. So this is a very important topic. So the outcomes are students learn the applications of matrices. Problem is find the circuits in the network shown in the figure shown below by matrix method. So this is a circuit form. So here is we can take this one is two type of equations. First one is upper of, second one is below of. So based on this you have to find the equations first. So then after using the matrix method we have to write in the 3x3 matrix form. So here is I will tell how to write the equations, but here is important thing is you have to know the Kirchhoff law equations based on the flow of current here. So the Kirchhoff law is nothing but these are Kirchhoff law equations. So I1 plus I2 equal to I3. So these are main equations. These are fixed one. Okay. So I1 plus I2 equal to I3 by using Kirchhoff law. Then based on the current, first we can take upper of here. So upper of is, so here is we have to take this 2. So 5I1 plus 10I3 equal to the output is 220 volt. So this is a method. So 5I1 10I3 equal to 220 volt. So here is 5I1 plus 10I3 equal to 220 volt. And second equation is, so here is we are comparing these two. So here is 20I2 plus 10I3 equal to 240. So 20I2 plus 10I3 equal to 240. So again I tell here, so first we can take this upper half of the figure, that is a circuit. So just we can comparing the volt here, that is this R omega. So that is we can take 5I1 plus 10I3 equal to 220 volt. This is the first equation. Second equation is 20I2 plus 10I3 equal to 240. So 20I2 plus 10I3 equal to 240. So this is based on the equations. Next we can rewrite this one is in terms of, so first I can take these equations. So 5I1 plus 10I3 equal to 220. Second one is 20I2 plus 10I3 equal to 240. Then third one is I1 plus I2 minus I3 equal to 0. So here is I3 comes your RHS, means we get negative value. So we can equate in the one equations form. Next we rewrite these equations in terms of matrices form. So first we can take first column is I1, second column is I2, third column is I3. Means, so here is I can write 5, 0, 10, 0, 20, 10, 1, 1, minus 1. Here is I can take I1, I2, I equal to 220, 240, 0. Just we can multiply this. So 5I1 plus 0I2, then this one is I3. So 10I3. So 10I3 we get equal to 240. Second one is 0I1, 20I2 plus that is 10I3 equal to 240. Then I1 plus I2 minus I3 equal to 0. So these two are like a same common equations. So this is equation form, this is a matrices form. Therefore we can rewrite this one is in terms of Ax equal to B, where A is nothing but the matrix 5, 0, 10, 0, 20, 10, 1, 1, minus 1. Then X stands for I1, I2, I3. Then B stands for 220, 240, 0. So comparing these two equations. So here is we have to find the amplitude of the current here, that is X I want. That is I want I1, I2, I3. So what about X here? So X equal to A goes to your RHS, means we get A inverse. So X equal to A inverse of B. How we will find the A inverse? So A inverse formula is 1 by determinant of A into adjoint of A. So we can find 1 by 1. So first I can find the determinant of A. So determinant of A equal to, we know the value, how to find the determinant. So value is minus 250. Then next to find adjoint of A. What is adjoint of A formula? Cofactor of volt transport. So first to find the cofactor of the matrix. So this is a cofactor of the matrix. method here. So first we can take positive, negative, positive, negative, positive, negative, then positive, negative, positive. So these are cofactors. So the given matrix, first we can change, this is a given matrix, first we can change positive, negative, positive, negative, positive, negative. So then after we can find the cofactors. So first cofactor means first we can take the first element. So 5, first I can take 5 means we can omit the first column, first row. What is the remaining value? So minus 20, then minus 10. So we get minus 30. So answer is minus 30 here. Okay. Then we can take the second value. I can take next one is 0. So we can omit the middle column, then first row. Remaining is 0 into minus 1 is 0. This one is minus 10. So our answer is, so 0 means we can omit this column, then this row. So this one is 0, we get minus 10. So we get minus 10 here. I think 15 is not 10, no, here is minus 10. Then third one is, we can take 10 means, so omit this column. So we get 0 minus 1 is 0, that is 0 minus 1 is 0, we get minus 20. So therefore answer is minus 20. It's based on same thing here. So we can take the cofactors, each and every elements we have to find the determinant value here. So we get the cofactor of A. So therefore adjoint of A equal to cofactor whole transport. So we can take the cofactor transport here. So we get minus 30, 15, minus 20, 10, minus 15, 5, 200, minus 50, then 100. But here is this one is 10 here. So replace this value. So okay, don't consider this video. So replace the value here is 10. So therefore what is the A inverse? So A inverse equal to adjoint of A divided by determinant of A. So that is equal to minus 1 divided by 250, then the remaining matrix, that is adjoint of A. So next we can find x value. So x equal to A inverse of B. Therefore x equal to I1, I2, I3. That implies A inverse of B. Here what is A inverse? Adjoint of A divided by determinant of A into B. That is equal to minus 1 divided by 250. Then A inverse. Then what is the B value? 220, 240, 0. That is equal to, we can multiply in the, so here is we can multiply. So first row, first column. So that means minus 30 into 220, then 10 into 240, minus 200 into 0. So then we can divide by minus 250. So we get 16.8. So here is answer must be differ. Okay. So y means here is this one is 10. Okay. Verify the answers. Then last value is 22.4. So this one is nothing but I1, I2 and I3. Therefore, the current passes through the circuit is I1 equal to 16.8 amplitude, I2 equal to 1.2 amplitude, then I3 equal to 22.4 amplitude. So just we can verify the answers here. I2 must be differ. So here is answer must be 10. Again you can recall you. Okay. So write your own thing here. So find the one by one here. So your work is how to find the cofactor of A. So this you have to find the cofactor of A, then take the transport, then after you can apply the formula is x equal to A inverse of B. So we get the required solution of this problem. Okay. So we will continue the next sections. Thank you.